Yeah, so as already mentioned, I'm going to talk a little bit about model versioning and variant management. Well, these are two quite interesting topics, and I would like to give you an insight on what is possible with the combination of various tools um, in order to achieve or basically manage both these aspects. So the timing aspect, model versioning, and also the kind of space aspect, the variants that are also very important to maintain through the life cycle of a project. So my name is Philip Kalender. I work at Liebe for more than 10 years now. I initially started as software developer, and nowadays I'm responsible for the consulting and training at Liebe. I work with various customers, helping to set up the toolchain. And as you've seen in the slide or the announcement of this session, Daniel is not here. Sadly, he couldn't make it, but he helped me set up this presentation. He helped me really a lot with setting up the Git workflows and so on. So really much appreciated. And yeah, he is still with us in the slides and in the presentation, but not physically attending and presenting. So I will take over for him. Short words about like the company, Liebe. So we are an Austrian-based company. We have the headquarter in the capital of Austria, in Vienna, and we also have a second office near the Alps. It's near to Salzburg in Bad Ischl. And basically, what we do is everything that has to do with models, model-based software systems engineering, infrastructure for modeling, data integration, and of course, trainings and consulting in the field of MBSE. And of course, we are also related to Spark Systems. So there is the Liebe Group where Peter Liebe, which you have heard him today probably already, you will hear him again today later on, is the owner and founder of Spark Systems Central Europe, which is a sister company of Spark Systems. And Liebe is in the same group of companies and therefore is a partner of Spark Systems. This is why we are specialized in developing tools, products, and solutions for the Spark Systems ecosystems, basically. Good. So let's dive into the topic. So I will talk a little bit about the concept behind it. So versioning, variant management, why is it necessary? What is the problem that we want to solve with that? And I also want to explain one approach that can help to deal with these disciplines. At first, I'm going to explain this on the theory level, so I'm using some slides to explain this concept, and then later on, I will try to show you this in the concrete tools. So bear with me, there will be a lot of tools involved. I really like to give you a deep insight of what is possible. So it's not just a theory talk, we will also do this in the tool, and I will also do it live, so no video recorded, so otherwise it would be boring, of course. So about the config management, so what do we have? Usually we have a model. So this problem, you can talk about this no matter if it's a model, source code, or anything else. For now, or for today, we talk about this in the model context. So we have a model and we work on this model with probably multiple people. And then we have a second version of this model and we have a third version, and the model basically evolves over the course of many days, months, and years. And the problem is that we cannot really keep track of what has changed. There are several practices to do that. You can use baselines, you can use backups, and you can, of course, also use version controlling. So I'm not talking about any specific approach there, but just the principle of version controlling, keeping track of different versions, not in the model itself, but in some external system. Uh, and the question is, how can we track the changes, and not just track the changes, but control the changes? So if I've done something that is not right, I want to revert it back to maybe a previous version. I want to see how the model has evolved. I want to be able to control different variations of implementation, maybe different projects, different kind of implementations. So the answer for that is config management with a version control system. So the typical approach that you know from software engineering where you have a version control system, something like Subversion, Git, or any other similar system. You have some branches. Usually it's a main branch, and then you branch off in so-called feature branches to have an own isolated development environment. And then after some time, you merge it back. You probably also do a review before merging back. For this, you can also combine it with some other tools in the Sparx ecosystem, like Prolaborate or ProCloud Server, to see the changes in a global environment. And if it's good and if you have reviewed it, you then can merge it back so that it's always maintained in the main branch. So this is pretty straightforward if you know that from software development, but that also works for a model, of course. A model is not as simple as a text because the model is not just simple lines and characters. It's a complex graph with diagrams, links, elements, and so on. So, of course, comparing changes and merging changes, if you have parallel changes, is not as simple as with text, but there is tool support for that. So this is something, if you probably know the believer, then you know this is not something new. We have the tool called Lemon Tree. This is something that is around since many years, and quite a lot of customers have this already in the use. So now the question is, what is the innovative part of this talk here? So well, we have a second area which is quite interesting, and based on my experience, always something that people like to see and know how to deal with it, but I have not yet came across a good solution or not really found a good way to deal with this until now, of course, because now there is a new development and something that we figured out that is quite nice to see that these two disciplines work together hand in hand. So I'm talking about the product line engineers. If you have multiple products that have some relations to it, because they are quite similar or maybe based on the same core or the same technical basis, the same platform, you could call it. Famous example, if you take an Airbus, or yeah, you could take any other plane, but for the Airbus, for me, it's simple to distinguish it. You have the A320 family, and you have an A321, A320, and A319. They are based on the same platform and they have different characteristics, so different length and different amount of seats, but they have probably something in common. And also what is interesting here, so if they have something in common, if I fix a problem or if I install an update or whatever you change on the system, you might want to do this on all variants or all models if it's in the common core, of course. So how do you deal with that? Well, you do this with variant management. At first, you have to define which are the common features. So what is common across all the platforms? So this would be defined in a so-called feature model. And then you define the different configurations of the variants in order to know this specific variant has only these kind of features, but they still have the same common core. So if something changes in the foundation, you should be able to take this over in all of the variants. So for example, we have the common A320 family, and then we have the derived variants, so A321, 20, and 19. They are built on based on the same platform. And if you now, for example, find a problem, let's imagine you find the problem in the common platform, then you want to fix this and of course propagate it to all of the other variants that have initially been derived from the common platform. And of course, the same is true if you find the problem in one of the variants. Maybe this is a variant specific problem, then you keep it just there and that's it. But if it's something that has an impact on the common base or maybe on the platform, of course, you want to fix this in the common platform and then propagate it again to all of the other variants. And you can see, so this is already including some timing aspect because you find this, you fix it, and then you publish a new version of whatever you are developing. So I'm talking really abstract. I don't really talk about the model, source code, or whatever. It's a basic concept that here you have to maintain these changes and have to have control over the changes, because you cannot just simply take the implementation or the fix from one of the variants and just apply it to all of the other variants. This wouldn't make sense, since the variants, they have differences between them. They have a common core, but you also have differences. So you cannot just blindly take that over. You have to propagate it in a controlled way. And this is now where you can take advantage of something that you perform in the version control context. If I flip it in the version control context, I don't really have this capability of dealing with the variance as if you would do it with a feature model, for example. So we really want to see if it's possible to combine these approaches. So the management of time versioning and the management of space, the different variants. So how can this be combined, or what is the advantage of combining that? So the versioning, of course, helps me to keep track of the history. So I know what happened to the system, to the model, to the source code. And I also have the possibility to perform a config management. So through the use of branches, for example, in Git, a branch, I can have different configurations or different variations. So here it's a bit hard, because variant in the Git context you could also use as a term, but it's not the same as in the variant management, but you will see that later on. But you can maintain different states of your artifact that is version controlled through the help of branches, which makes the integration and reviewing and also merging much easier compared to if you would do it in just one single branch and one full repository. And on the other hand, the variant management, it helps to create concrete models based on a feature configuration. So I have a list of features. The features might have different constraints between them, and I maybe don't need to know in the model which features belong together or which features have relations to each other. This is maintained in a dedicated tool that is dealing with feature models and feature configurations. And of course, I can take this as an input for a so-called transformation. Transformation takes a model that has different variations and then basically strips the model in order to get one concrete model that only contains one valid variant configuration. So this is the background of it, what we want to achieve. And of course, we need to use tools for that. Doing this by hand is not really a good approach, because it's quite error prone, as everything that you do which is done manually. So of course we use tools for that. Since the subject for variant and version management will be an enterprise architect model, I use of course enterprise architect to create, maintain and update the model. But then I need to use tools that are capable of version controlling and variant management. So here's a short overview of the tools that you're going to see in the demo in some minutes. So for the versioning, we will use Git as the version control system. We will use SmartGit as the Git client. There are plenty of Git clients that I can use, but SmartGit is quite handy because it also has a support for branching. It has a wizard that helps me with integrating branches, and it also has a nice visualization of the branches and how they are diverging or if they have been merged back. For seeing the differences between commits and branches, I use Lemon-Tree as the diff and merge tool. So in order to see that visually and to detect if a model is in a conflicted state because of changes between different branches, I have to use Lemon-Tree as the specialized diff and merge tool for an enterprise architect model. And finally, for the variant management, I use Pure Variants by PTC. This is a tool that is capable of defining feature models, defining variant configurations based on these feature models, and then taking an enterprise architect model, assigning restrictions and constraints to elements in order to link them to features, and then through the help of a transformation, create a concrete model that only contains a certain variant based on a feature configuration. And this what you will see then is based on the concept that is called 150% model. So why is it called 150%? It contains more than just one variant. It contains all possible variants. And it's called 150% because in the real world, or if you would then apply the transformation, you wouldn't have all the variants combined because the variants altogether doesn't make sense. Going back to the example of the Airbus, of course, I don't have in one Airbus model both of the configurations of the A320 and the A321. That's physically not possible. So that's why in a base model I have 150%, so an overview of all variations and different configurations. And the variant that I derive is then called the 100% model. This is then the concrete model that is the result of a transformation. And in this concept, we have an enterprise architect model that contains this 150% information. And then for each variant that we want to maintain, a variant is the concrete result of a transformation based on a configuration. This is maintained as a branch in the version control system. This works with any version control system. For today's example, I'm using Git because it's quite well known and quite handy to use, but you could in theory also do this with other or similar version control systems. So each variant is then maintained as an own individual branch, and for updating the variant, I'm using feature branches. So basically, I'm creating again branches based on my variant in order to deal with the daily work and to integrate changes continuously. And now you have different scenarios for updating. So of course, the variant model, this 100% model, is continuously developed. So this is the real model that you would use in a project. And then you still could have changes in the 150% model. If you think back of the slide that I showed before, if you find a problem in the common platform, this would be a change in the 150% model because you fix something. And this leads, of course, to new transformation. And this has to be updated and propagated to the variant branch. And additionally, what makes sense is that each starting point of a variant or a transformation can be tagged in Git. So a tag is basically just a label that basically just applies a name or label to a version so that you can always jump easily back to a starting point. For example, before you initiated the transformation, you create this tag so that you have a good overview in the history where you started off with a new variant or maybe a new transformation. So here is an overview of one possible workflow. So bear with me, it looks a bit complicated, but I will break it down. So these are the two models. So this is basically our initial state, the 150% model, where we have all of the features combined. And then through the transformation where pure variance is used, we get this 100% model for one concrete variant. I can have multiple variants based on the configuration. Here is just an example of one variant, but of course you can have multiple variants in parallel. And both of these variants are maintained in Git. So the base model and the variant is maintained in Git. The 150% model, the common platform, is maintained in the main branch, and the variant is maintained in its own dedicated feature branch, or we could also call it variant branch. And both of these branches or models will be extended and continuously developed. So for example, here we have a new version of the 150% model, for example, a fix that is applied. So this results in a new transformation, and this transformation result needs to be integrated into the variant that also has been continuously developed. So if I just take this and replace the variant model, I would lose the intermediate changes that have happened because this is a real model where people work on. So I need to take care of this. And this is done in a Git approach where you use different branches to maintain these parallel changes. So whenever I want to do a change in a model, I create a so-called feature branch, I work on this, and if I finish with the feature, for example, adding a new requirement, adding a state machine, I will merge this branch back. And once there is a new transformation result, so an update coming from the common platform, I also create a dedicated branch, which I would call an integration branch, for example, that uses the transformation result, the current version from the variant, and then Lemon Tree is doing a merge with the help of Git to combine the changes. So the updates from the common platform and the changes that have happened in the meantime. And the goal for this is not to lose any changes, because if I just blindly take the variant, the base update, then I would lose the intermediate changes from the variant. So with the help of version controlling and also with a different merge tool, I can see what has been changed. And if there is a conflict, because changing something in this common platform and changing something here in the variant model can lead to conflicts, because these changes can relate to the same elements. So this is detected by Lemon Tree, and then the merge is performed, and after a successful merge, we can then continue working on the variant. And so here we have a new version of this variant branch. And the idea of this is that you can always see the development and how the changes are evolving in the model. So at any time I can compare my current variant branch to the common base to see what is the difference. So what is the difference in the 100% model compared to the 150% model? I can always go back in time and take a look, how have the changes from version 0, from version 2 compared to version 0 affected the model, affected the transformation. So all these things are possible if the model is maintained in a version control environment. Just imagine if you would do this somehow by hand, by copying files or doing backups. It would be possible in theory, but it's really hard to do and really error prone, because merging things and sometimes also merging automatically is only a good approach if you do this assisted by, for example, a version control system, because the version control system already knows the best which versions to take, and also knows the common ancestors, which is always good to have compared to doing this manually. So that was about the idea behind it, and now I'm trying to show you that in some example. So basically, what you've seen here on the last slide, I will try to also show you right now live. Of course, I won't go into too much detail about all the Git specifics, because we don't have the time for that. But just to show you the strength of this full tool combination, what is currently possible. So I'm stopping my PowerPoint slides. And first, I will show you an enterprise architect model that I prepared, which I will use in this context, in this presentation. So it's a really small SysML model with some requirements. It's about just a car system, and it's really high level and just abstract, but I found there's some good features and combinations where I think every one of you can relate to this. So I have some requirements, multiple engine types, so gasoline and electric, so combustion engine and electrical motor, then manual and automatic transmission systems, and of course something for the transmission response time. And then also based on these requirements, we have a system architecture. So here I defined a block definition diagram. I'm quickly minimizing this so that you can see it a little bit better. So the car system consists of a certain kind of engine, combustion, electric. Then we have the transmission, manual and automatic. Then we have the chassis for a two-wheel drive and also for a four-wheel drive. And here you have 4 or 2 brakes. And here is the distinguishing between the rear and the front wheels, because of course the front wheels are powered, the rear wheels are not. And you can now see that this model contains all of the possible combinations. So we have a combustion engine, electric, manual transmission, automatic transmission, and the different chassis. So this is what I referred to before as the 150% model. And this is the practice to define the common base. So what is all, so there are some elements which are commonly shared, and there are some elements which are only specific in one of the variants. And you can see there are already constraints added to these elements. I enabled the constraints on this diagram, that here you can see, for example, this has the constraint electric. So now you might be wondering, what is this about with these constraints? So these constraints are connected to a feature model that is defined in pure variants. So now I'm going to switch into pure variants in my workspace, where you can see where I've defined a feature model for my car system. So from right now, this is independent from Enterprise Architect. I can define this without connecting to Enterprise Architect. Here I have different feature categories like the engine, then I have my transmission, I have my chassis, and you can see here we have different optional features or alternative features in that case. So here it's either a combustion engine or an electric engine. It's either automatic or manual transmission, and also for the chassis it's either a two-wheel drive or a four-wheel drive. And as you can see, you can also relate features to each other. For example, an electric engine, at least this was my assumption, that you have to require automatic transmission. So I cannot have an electric motor with a manual transmission. So this is my assumption. And this is why if I tick the electric feature to be enabled, I also require automatic transmission. I cannot combine electric with manual. So this is what I have defined here. So this is on the feature definition. Now the question is, how do these features here relate to the concrete elements in, for example, an Enterprise Architect model? So for that, I'm going to switch again back to Enterprise Architect, and here I have a pure variants add-in window enabled, where I can select a workspace, and then I can select here my feature model, or in that case a variant. I can see here we have my feature model available here, and if I want to add a constraint to an element, I can do that. For example, here with specialized, then pure variants, I can add a new constraint, and then I can use IntelliSense to see what are the available features. So this basically reads the pure variants workspace, and then I could, for example, say this here is related to the combustion feature. I already added this constraint, but this is how you would define the feature constraint, so that pure variants knows that everything that is related to the combustion constraint has to be then included or removed depending on which feature you have selected or which variant you want to generate. So now there is a connection between the feature model and the concrete elements, thanks to these constraints that have been identified. The same would also be applied to the internal block diagram. As you can see here, this is of course not the real IBD, because I cannot have manual and automatic at the same time, and also not electric and combustion at the same time. Of course, if we're talking about a hybrid, yes, but here we just stick to this example. So this is where you see that's the 150% diagram, and we will then reduce it to 100% later on. So now I'm switching again back to pure variants, because here I have now created some variant models. So for example, if I want to have a car with manual transmission, two-wheel drive, and combustion engine, I can create a variant model, and here I have access to the feature model. And you can now see that I can tick different features in order to define what is now part of this variant and which features have to be included in this variant configuration. As you can see, if I tick, for example, electric, then here I have to also select the automatic, and for example, two-wheel, four-wheel drive I can also tick. For now I want to, since I called this manual two-wheel drive combustion, I would take that. So combustion, automatic, not automatic, it's actually manual, and then two-wheel drive, for example. So I can save that. And I have a second variant here. So here we have automatic, two-wheel drive electric. So this is kind of inherited because here when I check the electric, it requires automatic. This is what I defined in the feature model. So it's implicitly also taking that, and I want to have a two-wheel drive here. So this is now the configuration of a certain variant. If I now go into Enterprise Architect, I can select one of the variants. I can, for example, take here this automatic two-wheel drive electric. And now I can also highlight on the diagrams which elements will be included in a certain variant. So if I tick this button here, it highlights the included elements. Now you can see it's a two-wheel drive, so this is enabled, automatic and electric. The same is also true for the IBD. This is inherited here because of the type reference, so we also see how this would look like after transformation. And the same is again true for the requirements. Since all of these elements are defined by pure variance constraints, this will be included and considered in the transformation. So now the question is, how do we deal with that in a version control environment? So I will quickly disable that so that we have the normal diagram again. So what I have done is I have this model here, the 150% model, version controlled in a Git repository. It's actually a GitHub repository, and I'm using SmartGit for that. So as you can see here, this model is checked in here. Currently it says that I have a change, so I will close the project and just revert my change because I don't want to have any intermediate changes. So that takes just a second. So this is my starting point right now, and what I want to do is I now want to create a branch for maintaining a variant here. So I will give this branch a prefix variant, and I will call this two-wheel drive auto electric. And this basically just creates a copy of the current state of the branch. And now I'm in this variant branch, and I use this prefix here so that I can easily identify if this is a variant branch or not. So now the model is still the same. So the 150% model is now in the branch as well. So what I now will do is I will start for this variant model the transformation. And the transformation takes the model and goes through all the elements and searches for the restrictions that we added based on the features, and then removes all elements which are not according to this current feature description. So I have this, as you can see, you can also see it here in the pure variance browser in the Git repository. This is my main model, and here I have a subfolder for the transformation results. So here I just transformed the automatic two-wheel drive electric. So this is why I have here this output. Here I now have the transformed model. So I can now take a look at this model, how this has been changed. What I will do is I will simply just take this and replace my Git model with that. This is a manual step that I'm currently doing because I want to control when the change is propagated into Git. Of course, you can set up the tool environment so that this is done automatically and that you transform into the Git repository directly. But for simplicity, I'm doing this here manually to control when the change is happening. So as you now can see, the model has changed, and we can now take a look into the model. What is the difference here? So if I go into the Git repository and open up the model, we can now take a look if the transformation did its thing. So here we can now see there is only the electric engine, the automatic transmission, and if we take a look in the system architecture, we can now see, well, yes, the four-wheel drive chassis is gone, automatic is still there, and the electric motor. So the other elements have been removed. So now I have my 100% model according to this configuration that I'm now maintaining in this branch. So what I now want to do is I want to commit the change. So because I've changed something in the variant branch, so I'm pushing the commit, so the transformation result to Git. So this is the two-wheel drive. And since this is now in Git, we can basically take the base version where we branched off and my current change in the variant branch, and I can simply ask it what is different between these two models. So I can show the changes, and this basically just triggers lemon tree, which gets the model files from the Git repository and calculates the difference between the two commits that I've selected, in that case the two branches here. And of course, we have quite a lot of changes because the transformation removed quite a lot of elements depending on the feature selection. So here in the requirements diagram, you can now see that some elements have been removed. And in that case, the elements that are related to combustion and manual transmission, since we don't need them because it's an electric engine and an automatic transmission. And of course, that's the same for the system architecture diagram. So here, if we take that, we can see here that's the 150% model on the left side. On the right hand side, we only have the 100%. So here, also in the internal block diagram, it's in the car system. There we go. We can now see it's now reduced to the concrete model and just got rid of the four-wheel drive since we don't need that, and also the manual transmission and also the combustion engine. So now we have an own dedicated branch for maintaining this variant, and this is a permanent branch. This will stay because I want to keep track of how this variant is evolving within this branch. So what I now will do is I will simply go ahead and work on the model. So I open this model again in the Enterprise Architect, and now I perform some changes because this is just the raw result of the transformation. So I probably need to fix the layout here because there are some elements which are gone. I'm just moving this to the side here so that it's not using it's using the leftover space from the removed elements. The same is true here in the internal block diagram. I can move this here because I have much more space now. And since the model is maintained outside of Enterprise Architect in Git, I always like to close the model because the Git operations can modify the Enterprise Architect model, and Enterprise Architect is not quite happy with changes that are happening outside. So it's always good to close the model. And now you can see again, I have a change. So this change I will commit to the branch. I will call this cleanup after transformation. So now we have an transformed model, and now we have our own dedicated branch to maintain that. So if I now quickly come back to this workflow in the slides, we pretty much did the left part here. We have a 150% model. We transformed, we created a branch, and now we changed something. I simplified it, so I'm not using this feature branch here for the sake of time, but this is currently where we are at right now. So we have now V1 of the 100% model. So now what I want to show you is how to integrate the change from the common platform. So what happens if the 150% model is updated? So I can very simply do that in Git. So if I don't want to work on this variant, I simply switch the branch. So I double click here the main branch and I check out the main branch. And as you can see here, so this is really what I like at SmartGit, that here in the middle, the graph is showing. So I can see in relation to other branches how my branch is looking like. So for example, this is the common base. The variant now has evolved and has two commits that are here already created. So I go back to the common base and I now perform a change in the common base here. So I will again open up the model. I'm right now in the main branch. I'm not anymore in the variant branch. So in order to find that out, you could use, for example, the Lemon-Tree add-in that also has a Git support. And here you can see that I'm in the main branch currently. And also in the output, you can see here it says current branch main, so that I'm not confused where I'm currently sitting at. So now let's say that I perform a new change. So maybe I want to rename, let's say here it's called rear wheels. Maybe I want to call them back, just as an example, because this probably has an impact on some variants, not all variants, so only the variants that include the two-wheel drive chassis, but I'm changing something here. And maybe I could also do a more fundamental change. I could say, well, this is the just car. I'm just removing this car system name. This will affect, of course, all of the variants because at the end I'm building a car in a concrete model. So coming back to Git, of course I have local changes. So updating common model, renamed rear to back, and car system to car. In reality, the commit messages are not as precise as here, but just for our overview so that we understand it better. So now I have a change in the main branch, and now you can see that the variant falls behind. So what do I have to do here? Well, what I showed you before, we have to get again a transformation from the new version of the common base and then integrate the changes from the new transformation result and the intermediate changes that have happened in the feature branch or in the variant branch here. Because if I would simply merge that, this would not happen. I cannot simply take the new transformation result and just replace it, because then I would be again here and I would lose the intermediate changes. So I want to combine the variant specific changes and the common changes. So how do I do that? Well, I will again create a branch, but for this I'm creating an integration branch. So what I will do is I will create, based on the main branch, I will create yet again another branch. I will call this integrate base change 001. So in the real world, this would be related to some ticket, a Java ticket or something else, an issue in GitHub where you can relate to. So maybe the issue ID at the end. So some concrete task that you have to perform so that in the version history, you can always relate to a ticket that is associated with a change. So what I'm now doing is I create a new branch, an integration branch, and I want to now perform a transformation with the current state of the main. So this is where we are currently here. We've changed the main branch. We want to run a transformation and then in this intermediate state here, merge it together. So how do I do that? Well, I will go again back to pure variance. I'm still using this variant model here and I'm going to run the transformation, just checking if I have Enterprise Architect closed, because for the variant transformation, you also need to close the model that is used for transforming. So this takes a few seconds and this will take the current model that I have in the main branch, or in that case in my integration branch, and use it for transformation. And again, this will be placed in the transformation result here. As you can see here, it was just written. So we now take this and just checking if I'm in the correct branch here. So I'm in the integrate branch, so I will update the model. And we can now see we have a change again. So this is now the transformation result. And I'm doing this in this integration branch in order not to destroy either the variant branch or the current main branch. This is why I want to make it controlled and have it in an isolated environment. And now the beauty of the version control system is, since each change is associated with a commit and I have it in dedicated branches, I can always compare the different commits to each other. So for example, if I want to now see what happens if I were to compare my variant branch here with the intermediate changes and the integrate branch, because I want to integrate at the end these changes into my variant branch. So I simply select the two commits, the two branches, and I request the comparison of that. So I'm just calling show changes. SmartGit will trigger telemetry, provide the files necessary for the comparison, and then we will see what will happen if we are to merge the two branches here. So we can see we have quite a lot of impacted elements. This makes sense because I'm comparing some transformation result here. So let's take a look. Of course, what we can always see is that this four-wheel drive is not existing because we are comparing it against the common base. So this is something we always see. We are comparing two 100% models against the 150% model. So it's a three-way comparison in case of having multiple branches. So this is why we see here the difference that this four-wheel drive you see is not existing in this branch here. But more interesting is the direct changes between the two branches. So as we can see here, we have a change here. This is what I have done in the main branch. I renamed this from rear to back, and also I renamed the car system to car. And this is all good to know so that I know the impact of my changes. But what is really interesting to see is if there are any conflicts that have been produced by this transformation and intermediate changes. And we can see, luckily for the elements, I don't have any conflicts, but for the diagrams, I happen to have one conflict. So we can quickly check what this conflict is about. So it's in the system architecture diagram. Let's see. Well, it's modified on both sides. So the car block here. So yeah, we have some conflict in the style leg, so this is fine. This is something we can ignore. It's internal enterprise architect data. So if we don't have any other conflict, I'm quickly checking that, it should be fine. So this is good to find out if there are fundamental conflicts during the transformation and the changes. So what I simply can do is now I can switch to my variant branch. So now I'm switching the perspective, and now I can select my integration branch, and now I'm starting the merge. I want to create a merge commit for that. And now Git tries to merge it at first on its own. But I already know that this is not going to happen since this is a binary file. It's an enterprise architect file. So of course, I have to merge this with a specialized tool where I can again use Lemmetry for that. And to do that, I have to select the model file, trigger the conflict solver, which in our case is Lemmetry. And now Lemmetry tries to merge the two files from these two branches. If it's possible to merge without conflicts, Lemmetry will do that automatically. If it is not possible, then Lemmetry will appear. And as we have seen before, that there is actually a conflict, I have to resolve the conflicts and tell Lemmetry how to deal with that. So again, we already did the comparison, so we already know that we have this conflict here in this graphical properties here. So this is fine. I just selected, I marked this as reviewed. You can now see I don't have any other conflicts anymore. So this is fine for me. I can do a quick check if I have to resolve some layouting. It looks fine on the first look. So here, yeah, it will also take this compacted diagram. So I'm basically just starting the merge, exiting Lemmetry, marking as resolved, and committing the change to resolve the merge. And now you can see that I integrated the changes from the main branch, considering a transformation into the variant branch. And of course, I can do this for multiple branches in parallel. So I understand this is quite complex, but that's how it is if you're dealing with multiple variations and multiple versions. But the good thing is you always have it under control, because in the version control system, at any time, if you screw something up, you can at any time go back to a historic commit. You can always compare the changes. So with this, you always have the backup of having the version and the history always at hand. So this is what makes it really interesting. And of course, the capability in pure variants to have the configuration and the different variants also visualized in Enterprise Architect. This is quite good to have. So then this helps you with this aspect, so the variants and the versions that are covered by Lemmetry and Git. So this, of course, is just the beginning. We are working with PTC there on trying out new combinations of our tool and pure variants, and with Enterprise Architect, of course. So there will also be a much more integrated merge in the future. So if you're interested in that, just talk to us. We can yeah, explain what is planned there and how you can have different variations and scenarios of this workflow. So we are happy to support you there, and also to get your feedback on what you would expect from such a workflow. So having said that and keeping an eye on the time, that's pretty much it from my side, what I wanted to show you. I hope I have not flooded you with too many information, and it was quite interesting. So now I'm open for any questions about my talk.
Thanks, Philip, for your insightful presentation on model versioning and variant management. We do have a few questions. I'll just relay them for you. So this is a question from Danny. Can you do changes in the variant and push them back into the 250% model?
Yes, you can also do that. For that, you have to be careful during the merge. So when Lemon Tree is performing a merge, it always tries to do that automatically. So that's the default behavior. So if you have two changes and the changes, they can be combined. So for example, you add an element and you modify another element, it will be combined automatically. If you merge from the variant back to the base model, you don't want to have this automatic merge, so you have to do a visual merge. This is something you can configure in Lametry, that Lametry always shows you what it would do in case of a merge. And for that, you would need this visual merge, so where you can then say, well, this is the variant specific part. I want to leave that in the variant, but I changed in the variant something that belongs into the common base, so you can explicitly or selectively take over a change during the merge. So this is always possible, but of course is a bit more, I wouldn't say time consuming, but you have to be more careful and make it more explicit, and you cannot do this in an automatic way.
Thanks, Philip. And we have a question from Robert. From your experience, what are the critical factors to consider when transitioning from traditional product development to a product line engineering approach?
I would say really to know the relations between the different variants and features, and also not to over engineer it. I mean, but so not everything is a feature. Maybe not everything is worth to be maintained in an own variant. So it's always nice to see all these different variants and have maybe 20 variants at once, but maybe that's not something that you need. So this is something you have to be careful. Otherwise, yeah, I think really this just doing only the variant handling is not enough, and just doing the versioning is also not enough. So this is why we wanted to look at this, that we think that always the combination has to be tackled, and it's quite challenging because it is complex. So I would say this is quite something you have to keep in mind.
Thanks, Philip. Uh, we'll just post the rest of the questions on the Slack channel, and all the attendees can get their answers from Philip there. And once again, thank you, Philip, for your insightful presentation on model versioning and variant management. We appreciate your perspectives on product line engineering. We hope our audience finds the information helpful and are eager to implement them with their own projects. Dear attendees, if you have any other queries, please feel free to continue the discussion on our Slack channel, where Philip will be available to provide further answers. Thank you, Philip.
Thank you very much.